Okay, hello guys. Today we're gonna be doing the physics quiz for term 2, week 1. And yeah, let's start. Okay, for the first question, which of the following are fundamental types of forces? This is just memorizing. You need to memorize what they are: gravity, electroweak forces, and strong forces. Okay, next question. What are the forces? A cart moving along a rough horizontal surface will eventually stop. What forces makes the cart stop? Now, a force that acts between a moving object and the surface is always going to be friction. So that's for A. For B, where does the force act? The force is the action between two forces. And here the two interacting forces are the cart and the rough horizontal surface. So the force is going to be acting between the cart and the rough surface. Okay, question 3. Push or a pull is the definition of a force. This is just memorization, and a push or a pull is the result of an interaction between two objects, which is basically the definition of a force. It's an interaction between two objects. Okay, on to question 4. Okay, each square is 5 newtons. So here all you need to do is really count. We have to the left 2 squares, which is 10 newtons. And to the right we have 1, 2, 3. So this is 15 newtons. And we have 1, 2, 3, 4, 5, 6. Which is 6 times 5 newtons is 30 newtons. So we have to add the ones that are on the same side. So it's 30 plus 15, which is 45 to the right. And we have 10 to the left. So we subtract them, we're going to get 35 to the right. And the magnitude is 35. They're going to ask for the direction. Okay. Next question now. Question 5. Okay, so here for the rest of the solving questions, you really only need two rules, which are that the x component of the force is equal to the cosine of the angle times the force, and that the y component is equal to sine of the angle times the force. Okay, this is what we're going to be mostly using for the rest of the quiz. So let's start for this question now. So we have this angle is 50. They want the horizontal and the vertical component. Horizontal is x and vertical is y. Okay. So the horizontal component is gonna be, as we said, f of x is equal to cosine of the angle, which is what, 50, cosine of 50 times our force, which is 10. So if we do it on the calculator, cosine of 50 times 10, we're gonna get 6.42, which is 6.4. Now the vertical component, we said f of y is equal to sine of the angle times the force. Also, if we do this on the calculator, you'll get sine of 50 times 10. It's 7.66, which if we round is going to be 7.7. So that's it for this question. You only really need to know two rules. Okay, here, to get the magnitude of a resultant force, we do the x component squared plus the y component squared. It's going to be equal to our force squared. So basically Pythagorean theorem. So here we have 7.5 and 10. So it's going to be 7.5 squared plus 10 squared is equal to our force squared. So we do this on the calculator. 7.5 squared plus 10 squared is equal to 156.25. We have to get this radical to get rid of the square. So it's going to be 12.5. That's it for part A. Now for part B, okay. For part B, we got that this force is 12.5. So we need this angle. Now we said that the x component is going to be equal to cosine of the angle times 12.5, which is the force. So we have that x is 10. We take 12.5 to the other side. We're going to get 10 over 12.5 is equal to cosine of the angle. We take cosine to the other side. Cosine inverse of 10 over 12.5 is equal, yeah, is equal to the angle. We do this on the calculator. Cosine inverse of 10 over 12.5. We get 36.86, which if we round is going to be 37. So that's it for this question. On to the next. Question 7. I skip a question by accident? No, I didn't. Okay. Question 7. They said friction is negligible. So the only frictional forces are friction and air resistance. So if friction is negligible, then air resistance is going to be the only remaining one. Now, question 8. Okay, this question is a bit needs a little bit of solving, like a little bit more thinking than the others. So the horizontal component of the net force is equal to the horizontal component of the first force plus the second force. So we need the horizontal component of the first force. We said the horizontal component is cosine of the angle times the force. So it's cosine of 30 times f of the x component is equal to cosine of 30 times 10, which if we do on the calculator is gonna give us 8.6, 8.66, which is 8.67 basically, but let's keep it 8.6, yeah, 8.67, okay? Yeah, 8.67. Now for the second force, F2x is gonna be equal to cosine 45 times the force, which is 10. We do this on the calculator, cosine of 45 times 10, we get 7.07. So the horizontal component, which is the x component of the net force, is this plus this, which if we do on the calculator is gonna be 15.74, which is, if we round, 15.7. So that's our first answer. Okay, for the second, we need the y component. We said the y component is equal to sine of the angle, sine of the angle, whatever it is, yeah, times the force. So here we have that the angle is 30 and the force is 10. So the y component is equal to, sorry, the y component is equal to sine 30 times 10. So if we do this on the calculator, you'll get sine of 30 times 10 is equal to 5. For the second one, we have to do the same thing. So it's gonna be, I'm sorry, it's gonna be sine of 45 times 10, which if we do on the calculator, you'll get, yeah, sine of 45 times 10. If we do that on the calculator, we'll get 7.07. Now, for the second force, it is directed downwards, which means that its y component is going to be negative. So this is actually negative 7.07. And we got for the first one, it's 5. So the y component of the net force is the y component of the first force and the second force combined. So if we do this on the calculator, we'll get negative 2.07, which is our second answer. And yeah, now, okay. Now for the third one, the magnitude of the net force, we said that we use Pythagorean theorem. So it's gonna be 15.7 squared plus the answer that we just got. So I prefer you put on the calculator 15.7 squared plus answer squared, since we have a lot of decimals after the second one, this negative 2.07. So plus answer squared, which is negative 2.07. Let's keep it like as answered since we have a lot of decimals, so it becomes more accurate, is equal to R4 squared. So if you do it on the calculator, you'll get that this plus this is 250.77. Get the radical to get rid of the square. So radical of the answer is 15 0.836, which if we round is just 15.8, which is our third answer. What's the next question now? Okay. The force exerted by air to slow down an object. Okay, this is always going to be drag. The attraction of earth is weight. Swing cord, any cord or rope is tension. And between a surface and anything moving on it is going to be friction. Okay, next question. Okay, now. Sorry, I had to get a bottle of water. Anyways, the magnitude of the net force, we said we're going to use this squared plus this squared plus this squared. But here we have 19 up. We said that it's going to be the y component squared plus the x component squared. This is our force squared, right? But here we have 19 newtons up and 3 newtons down. So from the 19 newtons, we're going to subtract 3. So it's going to be 16. So our net force is going to be 16 squared plus 12 squared is equal to our 4 squared. And we do it on our calculator. Plus 12 squared. We get that these are 400. We do the radical to get rid of the squared. So our force is 20. Okay, so that's it for part A. Now for part B, we got that this is, we got that this is 20. And we're trying to find this angle between the force and the horizontal, which is the x. So we're trying to find this angle, and as we said, the x component, which we got given as 12, is equal to cosine. So 12 is equal to cosine of the angle times 20. We take 20 to the other side, so cosine of the angle is equal to 12 over 20. We take cosine to the other side now, so we'll get cosine inverse of 12 over 20 is equal to the angle. We do this on the calculator, cosine inverse of 12 over 20. We'll get 53.1, which is, if we are going to be 53. So that's it for this question. Next question now. Okay, for this question, we need to find the magnitude. Now, we need to pay attention to the question. They told us that the net force acting on the particle is 0. If the net force is 0, that means that the particle does not move, which means that this force needs to be equal to this force so that the particle stays in place. So basically, if we find this force is going to be equal to it. Now we said we have the x component and the y component, and we said that the force is x squared plus y squared is equal to our 4 squared. So 8 squared plus 15 squared is equal to our 4 squared. So we do it on our calculator. 8 squared plus 15 squared is 289. So now we radical it to get rid of the square. Radical of 289 is equal to 17. And that's our answer for the first part, 17. Now for the second part, we got that this is, one second. We got that this 17, and we know that this is 8, and this is also going to be 15. Okay? So they want this angle right here. They want this angle. So we said that cosine, we have the x component. Now x component is equal to cosine of the angle times the force, which is 17. So 8 is equal to cosine of the angle times 17. We take 17 to the other side, 8 over 17. and then we take cosine to the other side. So we'll get cosine inverse of 8 over 17 is equal to the angle. We do it on our calculator. We'll get 61.9, which if we round is going to be 62. And that is our answer. Next question. Okay, we're going to use the same rules basically. The x component of the net force. So we need to find the x component of the first force and the x component of the second force. Let's start with this force. The x component we said is going to be cosine of the angle times the force. So we do this on our calculator. Cosine of 28 times 17. We'll get 15. Now, the x component of the second force is going to be cosine of 53 times 5, which if we do on the calculator, we'll get 3.00, which is 3. So now for the second force, since our force is directed to the left, to the negative side, this is going to be negative 3, since it's in the negative direction. So all we have to do now is to add them, to combine both x components. So it's going to be 15 plus negative 3, which is equal to 12. So that's our answer for A. Now, for B, the y component, we do the same thing. Y component is equal to sine of the angle times the force. And for the other force, which is this one, it's going to be sine of the angle, 53, times the force. So we're going to do both of these. Sine of 28 times 17, we're going to get 7.98. And for this, sine of 53 times 5, which is 3.99, which is 4, and this is 8. Now we have a third force here, which only has a vertical component, which is why we didn't use it in the first one. Only a vertical component means we just add it since, sorry, I meant, yeah, only vertical component. So it's only upwards. So we're only going to use it for the y component. We don't use it for the x component. So all we have to do now is combine all three forces. So we have this 8 plus, now as for the x component, the same thing for the x component as we did for the last question. Since this is directed to the left and downwards, both its x and y components are negative. So here this 4 is actually also going to be negative 4. So it's 8 plus negative 4. This 1 is directed upwards, so it's going to be plus 1. 8 plus negative 4 plus 1 is 5. And that's our answer for the second part. Is there a third part? Yeah, there is a third part. Okay. The angle between the net force. Now we need to actually find the net force. So to find this net force, we said we have to do the x component squared plus the y component squared to give us the force squared. We have that the x component, we found it to be 12 and the y component to be 5. So it's going to be 12 squared plus 5 squared is equal to our 4 squared. Now these give you 169. So we radical 169 to get rid of the 4 squared. So our force is going to be 13. So we know that our force here, whatever it is, it's going to be 13. Okay? So, second. So they want the angle between the net force and the positive x-axis. So let's say the angle is, this is the force. They want this whole angle. Now we know that the x component is 12. So our x component here is going to be 12. And as we said, the x component is equal to cosine of the angle times the whole force, which we said is 13. So times 13, we take, and the x component we said is going to be 12, which is what we already found here. So we get that 12 is equal to cosine of the angle times 13. We take 13 to the other side. cosine of the angle is equal to 12 over 13. We take cosine to the other side. Cosine inverse of 12 over 13 is equal to the angle. We do this on the calculator. Cosine inverse of 12 over 13, which is going to be 22.6, which if we round is going to be 23. And that is our answer. Next question. Okay, here this is also mostly memorization. You just need to know how the addition of forces get you a vector. So this is also mostly memorization. Okay, this is also memorization of how to denote forces. If it's force, a boy closes a door, so it's F1. F1 is the boy, and door is basically the second object, so it's going to be F of boy on door. A girl pulls a rope, F of girl on rope, and so on. It's just something you need to memorize. Okay, next. A force is a push or a pull. This is also a definition. And a force is a result of an interaction between two objects. This is also a definition. Okay. Tension is anything with ropes, cords, so on. A friction is between surfaces and anything moving on the surface. Upthrust is usually in liquids and waters, and normal force is the force that acts from perpendicularly uh, on a surface or from the surface. And yeah, that's it for this quiz. I hope you guys understood. If you need any help, uh, don't don't be reluctant to reach out to me. And yeah, good luck in your exams and see you next time. Bye bye.